talk. Thanks for sticking around. This one is Matt Moriello at the University of Maryland, and this is another honoree. They got the Honorable Mention Award for this work, so congratulations, Matt.
Hello, my name is Matt Morello from the University of Maryland. Today we're going to talk about something a little different, understanding the role of thermography in energy auditing. And so I'm going to talk about current practices and the potential for automated solutions. As has been pointed out previously, the building sector takes up about 40% of the energy consumed in the United States, and about 25% of that 40% goes into heating and cooling. And we can't stop heating and cooling our homes, but we can make them more efficient. So to talk about some reasons of inefficiencies, they include the design of the building itself, the materials used in the construction, and the age of the building. To address these, we generally apply renovations and retrofits to existing building stock, and this has become something of a priority for us in the United States. The Department of Energy has set, for example, a goal of reducing housing energy use by 70%. And one of the ways they promote doing this is through home energy audits. This has given rise to renewed interest in professional energy auditing, and they commonly identify building inefficiencies through walkthrough inspections, on-site measurements, and computer simulations. Frequently, these audits contain a thermographic component, and what thermal cameras allow you to do is see surface temperatures, and it also helps to visualize problems such as air infiltration. So this is where cold air might be seeping in through a door frame or around a window seal. Additionally, if you see sort of an uneven patterning, that might indicate that there's a problem with insulation. Now, a thermal camera works by detecting electromagnetic radiation, which is something that any object above absolute zero emits. And what the camera does is it sees this information and it infers a temperature value based on its calibration. Now, in the 1960s, these cameras were as large as television studio cameras, but today they conveniently fit on your iPhone. Similarly, prices come down. And so because of improvements in the technology and falling costs, auditors are increasingly using these in their inspections. However, energy audits and thermographic surveying are time and labor intensive. So researchers are asking, how can we potentially automate thermographic assessment? And when we talk about thermographic assessment, we generally talk about 4 different components. There's data collection, analysis, modeling, and reporting. So to automate data collection, researchers frequently look towards robotic applications. So here, Applied Geotechnologies Research Group at the University of Vigo, they use unmanned aerial vehicles to collect thermographic data, which gives you good access to inaccessible areas like rooftops. Jacobs University in Bremen, they actually use a ground robotics platform. Here they have mounted a LiDAR scanner and a thermal camera, and they're able to actually survey large urban areas. When we talk about automating analyses, we're wondering, if we're collecting all this data, what might that enable? So more frequent data collection might enable temporal analysis. Moving on, data collection, having more data, allows us to produce high-fidelity geometric models that we can then overlay thermal data. And this gives us a perspective of inefficiencies on the urban environment. Lastly, there's this idea of automating reporting. What we want to know here is, how will end users actually use the data? Now, one example might be providing energy efficiency recommendations to facilities managers. We surveyed the automated thermography literature, and we noticed that they weren't performing user studies. They were focusing on solving engineering challenges. And there was no investigation into how professional auditors may use or perceive these emerging technologies. That led to our research questions, which is, how is thermography currently being used by auditors? What benefits and drawbacks do auditors identify when using robotics to collect thermographic data? And finally, what are the implications that auditors have for the design of these tools? I'd like to go through our study design, summarize our participants, we'll walk through some of our results, and then I'd like to reflect on all this as well as what's going on today. So we conducted 2 studies. In the first study, it was broken into 2 parts, a semi-structured interview, as well as a presentation of design probes based on the automated thermography literature. We followed that up with an observational case study of a residential audit. And so in the semi-structured interview, we asked auditors about their background, how they get involved in energy auditing. We asked them about the types of challenges they face on the job. We asked them about what they thought their impact was on sustainability. And we asked them about what they thought the future of thermography was. We did this before going into the design probes so that we didn't bias their answers. Our design probes had 5 components. The first 3 were text scenarios. The fourth scenario was a video scenario. And the 5th scenario was a medium fidelity software prototype. For these scenarios, they increased in complexity as we went from one to the next, but they were all interrelated. Let me give you 2 examples. In scenario 3, you control a fleet of thermography UAVs that fly around semi-autonomously, collecting data about your campus. They produce high-resolution reports, they can access inaccessible data, and they enable historical reports, which allows you to observe performance over time. To give you an example of what that might look like, we'll turn to the video scenario. Here you can see an unmanned aerial vehicle taking off, acquiring a target, and approaching it. And it also has to react to the environment that it's working in, like wind. And so reacquiring the target and now turning on the thermal camera to collect the data that we're interested in. So in terms of the analysis of the study, we qualitatively coded the interview and design probe data to uncover themes. And now I'd like to move on to talking about our participants. We made a general posting looking for energy auditors who had hands-on experience using thermographic cameras. We used social media, particularly LinkedIn, to access the professional auditor community, but even using these tools, we still had to resort to cold calling, so maybe some of you can relate to this situation. You start going through a list in the morning, and you're very hopeful that it's going to work out for you. As hours and maybe days go by, you start to doubt that this is really going to work. And then finally, you might be exhausted. But hopefully you've been successful as we were. Our participants were recruited across the domestic United States, which means that some of our studies were conducted via Skype. They came from 6 states, and they had familiarity working in these general geographic regions, which gives us a nice cross-section in terms of the types of weather and building structures that they were used to working in. We recruited 10 participants, 1 female, the average age was 45, the average experience in the field, 7 years. In terms of their occupations, 2 of them were former thermographers, 2 of them were government, and 6 of them worked for private industry. Thermography training is actually really interesting because there's no official practice of requiring auditors to be certified in any particular way. So 2 had no formal training, some had received on-the-job training, and 5 had received professional thermography training. So this gives us a pretty good cross-section of the types of knowledge and opinions these auditors may have. So let's talk about the interview results. I'm going to generally summarize them as required knowledge, client interactions, and challenges associated with energy auditing. In terms of required knowledge, 6 out of 10 of our auditors felt that you need to have an understanding of building materials and the types of construction which were necessary for a proper thermographic inspection. Half of our auditors thought that you need to understand the physics behind heat transfer and airflow in order to interpret the results shown to you by a thermal camera. And participant 2 kind of summarized both of these points pretty well when he said that the thing that is most critical to understand is how heat behaves and interacts with different materials. Moving on to client interactions, this was probably the most critical point to having a successful energy audit. In terms of information gathering, no one knows better the building or the home than the people living and working in it. You also have to understand the client's motivations for having an energy audit. Some people have a comfort issue that they want to solve. Others may want to lower their utility bill. In very few instances, according to our auditors, does someone actually really be concerned about sustainability. There's also this idea of establishing trust. The auditors are going to give a recommendation that they want the client to follow. And so it's very important to establish trust between client and auditor. One method for doing that was to actually give the camera to the customer and have them look around. This is very engaging and opens them up to a discussion about the dynamics of what's happening. Also, it allows them to visualize problems in their own space. Now, there are certainly some challenges associated with energy auditing, especially where thermography is being applied. First and foremost among them are weather. You have to have at least a 10-degree difference between the internal and external temperature in order to perform a thermographic audit. Related to the industry itself, there's an issue of undertrained or undereducated practitioners who may review some data and make a recommendation that is wrong and thus damage the trust relationship and perspective of energy auditing that clients have. There's also unanimously agreed upon a difficulty in interpreting the results. It's a subjective and qualitative practice largely, and the reality is that you can have three guys with the same camera looking at the same thing and have three totally different reports. It's kind of a problem. So automated solutions will have to bring consistency to this picture. Now, in terms of our design probes, I want to talk about the benefits and the concerns that were brought up. So our auditors, the first benefit they saw was saving them time and money. They also liked the idea of being able to assess inaccessible areas, and by using robotics, this does become somewhat safer. Moving on, there's the potential to scale up data collection. We've already said this is a time-intensive activity, so if you can survey multiple buildings simultaneously, that's generally considered positive. There's also this idea of looking at new types of analyses. Here is a server room being modeled by an energy modeler, and they have the ability to look at airflow over time. And so our auditors are very interested in bringing this to the built environment, to buildings and homes and commercial buildings, in order to be able to look at these things over time. The idea here is that maybe you could look at a problem and say, for 4 months we've had this problem, maybe we should look into seeing it, or to fixing it. This provides evidence that supports the recommendations that they're making. There was interest in automatic anomaly detection, as well as automatic model generation. Here we want to be able to automatically generate the geometric and the spatial relationships, as well as overlay thermographic data on top of this, because energy auditors spend a lot of time modeling the building, measuring the outside of the house, counting the windows and the doors, and looking around, and an automated system that could do this would streamline all that. Moving on to concerns. The first concern regularly brought up was the issue of data quality. There's weather to consider. There is a lack of control in the environment that automated systems will have to get over in order to collect proper data. Here you can see an energy auditor mounting a blower door in order to look at air infiltration. Automated systems don't really have the capacity to do that right now. Secondly, there's this idea of data overload. If we're collecting orders of magnitude more data, we don't just want to shift the labor from collecting data to processing data. And so future systems will have to deal with this. There's also this issue of privacy. If we're collecting information at an urban level, who owns that data, and how do you opt out of having it collected about you? Also, it's unclear how automation may affect the social processes that are going on during an energy audit. It's a socio-technical process, and it has to be addressed by automation. Now, in terms of our observation, we observed a residential energy audit. We recruited one thermographer, we gained consent to be there, we collected field notes, and we shadowed the participants. Largely, our analysis looked at the pictures, the field notes, and we extracted themes in the same way that we did for study one, and we primarily used these to help contextualize our findings. We got a chance to see how energy auditors collect data in the field. We got to see them perform tests. We got to see how they work with clients. So largely, our results corroborated what we learned in our interviews, but I would like to touch on client interaction once more. The auditor that we were working with spent a lot of time educating the client about what's going on in his home. And again, he tried to understand the motivation. In his experience, many people expect that their bill is wrong and that they don't actually have a problem in their home. And so again, the social processes and understanding the motivation and building that trust are all very important during an energy audit. So lastly, I'd like to reflect on some of what we've been talking about and look at some real-world applications. Automated thermography promises to transform how and where thermal data can be collected. What are the implications for privacy, and who owns that data? In Cambridge, Massachusetts, they're already seeing drive-by heat mapping. A company called ESIS is using thermographic cameras mounted to cars to collect data about the urban environment. And they then sell that data back to the utility company, who produces a report they can send to their clients with recommendations about how to improve their home. They've surveyed 17,000 buildings, and they've done this all without the permission of the owners. I don't know how you feel about that. It makes me feel weird. Looking at London, for example, they're using LiDAR and thermographic cameras to identify where people have erected illegal housing and whether or not it's occupied. So the automated literature has this process-centric slant, and consequently, they forget that this is a socio-technical process. It's about establishing trust, it's about helping clients to understand, and it's about providing good recommendations that will be followed. Just to talk a little bit about our future work, we'd like to continue to engage in the ethnographic fieldwork that we've started. We'd like to investigate computer vision algorithms to look into automatically inferring things about the buildings that would help make better recommendations. We'd like to explore the benefits of temporal analyses and automatic anomaly detection, and we'd like to examine opportunities for indoor thermography, which hasn't really been investigated by other automated systems. We'd like to explore privacy and what policy implications exist. And I'd like to briefly touch on our limitations. First, our auditors specialize in residential buildings, so there's the potential that auditors specializing in commercial or industrial applications would have different perspectives. Our design probe emphasized certain aspects of automation that we were interested in, and you could certainly envision other scenarios. Our study methods relied on self-report data and a single observation, however, we do want to continue our fieldwork. Lastly, there's this potential dichotomy in asking professional auditors about the scenarios that could be perceived as undercutting their jobs, but this was never raised to us during the interviews or during the audits that we observed. So in summary, this is the first human-centered study of thermographic automation. Through semi-structured interviews and our observational case study, we assessed energy auditing practices and thermography's role therein. Through our 5 design probes, we examined emerging automated thermographic solutions, and our findings have implications for the design of these tools. I'd like to thank my co-authors as well as all the support we've received from the Human Computer Action Lab. If you've never seen a thermal camera, I have it on my phone, so you can stop up after the talk to take a look. And at this point, you're welcome to ask me any questions. Thank you.